Shawon. A Boeing 737 was flying itself on autopilot over the Aegean Sea, holding a programmed cruise altitude, while everyone aboard had lost consciousness. The pilots were incapacitated in their seats. The passengers had stopped breathing, and Greek air traffic controllers, watching the aircraft circle on radar as though nothing was wrong, could not raise anyone on the radio. Helios Airways was a Cypriot carrier operating holiday and scheduled routes out of Larnaca. On the morning of 14th of August 2005, Flight 522 was scheduled to depart Larnaca at 09 AM, stop in Athens, and continue to Prague. The aircraft was a Boeing 737-300, registration 5B-DBY, manufactured in 1998. In command was Captain Hans-Jürgen Merten, a 59-year-old German contract pilot with 35 years of flying experience and 16,900 total flight hours, of which 5,500 were on the 737. His first officer was Pampos Karalambos, 51, a Cypriot pilot with 7,949 career hours and nearly 4,000 of those on the same aircraft type. A 32-year-old Greek flight attendant, Louisa Vouteri, was serving as chief cabin crew that morning, having stepped in to cover for a sick colleague. Normal procedure would have taken them over the Aegean, through Greek airspace, and into Athens by 10:45. What happened instead began before the aircraft ever left the ground. When Flight 522's aircraft arrived at Larnaca that morning from London Heathrow, the incoming crew had reported two problems: a frozen door seal and abnormal noises from the right aft service door. A ground engineer conducted a pressurization leak check to investigate. To run that check without the engines running, the pressurization system had to be set to manual. The engineer completed the check. Then, by the reconstruction of the accident investigation, he most likely forgot to return the selector to auto. The new crew performed their pre-flight checks. The pressurization setting was in the wrong position. They did not catch it. They completed the after-start check. They did not catch it there either. After takeoff, they ran the after-takeoff check. They did not catch it then. The aircraft took off at 0907 with the pressurization system still set to manual and the aft outflow valve partially open. As the 737 climbed, the pressure inside the cabin began quietly falling. At 12,040 feet, the cabin altitude warning horn sounded. The sound is identical to the takeoff configuration warning, which signals that the aircraft is not ready for takeoff. That warning can only trigger on the ground. Captain Merten radioed the Helios Operations Center and reported the takeoff configuration warning as active, along with a note that cooling equipment appeared normal. The crew were treating a depressurization alarm as a ground systems fault they had apparently carried with them into the air. Meanwhile, warning lights were accumulating on the overhead panel. Equipment cooling warnings illuminated, a consequence of reduced air density. The master caution light came on. Around 18,000 feet, the passenger oxygen mask in the cabin dropped automatically. The crew did not declare an emergency. The aircraft continued climbing toward its cruise altitude. Here is the detail that reframes everything. The cabin altitude warning and the takeoff configuration warning on the 737-300 produced the exact same sound. They are acoustically indistinguishable. The crew heard an alarm they believed could only mean one thing, and they were at altitude when it sounded, which should itself have ruled out the ground-based interpretation. The investigation found that this misidentification was the hinge point. A crew that understood the alarm as depressurization would have initiated emergency descent immediately. A crew that heard it as a takeoff warning while airborne would search for a different malfunction. That is what the record shows they did. At cruise altitude over the Aegean, with the cabin now effectively at the pressure of high-altitude mountaineering terrain, hypoxia would have progressed rapidly and without sensation of distress. The condition impairs judgment and self-awareness before it causes visible incapacitation. By the time a person at that cabin altitude understands something is wrong, the cognitive capacity to act on that understanding is often already compromised. Nicosia Air Traffic Control lost contact with the flight. Greek controllers observed the aircraft on radar, proceeding normally on its program course. Military aircraft were scrambled. When fighter pilots drew alongside the 737, they reported the captain slumped over the controls and no visible movement in the cockpit. The aircraft continued to circle on autopilot. The investigation by Greece's Air Accident Investigation and Aviation Safety Board established the chain with considerable confidence. Manual pressurization setting, missed on 3 separate checks, produced gradual cabin depressurization, which produced hypoxia, which incapacitated the crew before they correctly identified what was happening. All 121 people aboard died when the aircraft eventually ran out of fuel and came down near Grammatiko, Greece. It remains the deadliest aviation accident in Greek history. 2 explanations have been examined for why the pressurization selector was not caught. The first centers on the ground engineer. The investigation concluded he most likely forgot to restore the setting after the leak check. This is documented as the initiating failure. The counter evidence to placing all weight here is that the system then passed through 3 separate crew checks undetected, meaning the error survived multiple redundancies designed specifically to catch it. The second centers on crew procedure and alarm design. The crew missed the selector during pre-flight, after start, and after takeoff checks. Then when the alarm sounded, they misidentified it. Investigators found that the identical sounds of 2 functionally distinct warnings created genuine ambiguity. This is not a finding of incompetence in isolation. It is a finding about a system design that placed an identical auditory signal on 2 warnings with opposite implications. One that should prompt a ground abort, one that should prompt immediate emergency descent. Boeing and Helios Airways both faced legal action following the crash. The government of Cyprus shut down Helios Airways the following year. Regulatory responses in aviation focused on alarm differentiation and pressurization check protocols, though the specific regulatory changes that followed are not detailed in the available record of this investigation. What the case exposes is a specific failure mode in complex systems. A single upstream error, left uncorrected, propagating through multiple layers of design redundancy without triggering the response those layers were intended to produce. The 3-check system did not fail because the checks were skipped. The record shows the checks were performed. The setting was there to be seen on each occasion. Something about the context, the flow, the expectation of what would be found allowed it to pass unregistered 3 consecutive times. This is a documented pattern in aviation and other high-reliability industries, and it is precisely why alarm design, checklist ergonomics, and handover communication protocols have become focal points in safety engineering. The mechanism of the accident, as reconstructed, is largely settled. The initiating cause, the missed checks, the alarm misidentification, the progression of hypoxia, these form a coherent and evidence-supported chain. What the investigation could not fully answer, and what the record leaves open, is the exact cognitive state aboard during the window between the alarm sounding and final incapacitation. The crew responded to the alarm. They radioed. They searched for an explanation. How close they came to identifying what was actually happening, and whether any configuration of the cockpit environment could have made the correct identification available to them in time, remains a question the data cannot close. On the morning of 14th of August 2005, a Boeing 737 departed Larnaca with a pressurization selector set to the wrong position. 3 checks failed to catch it. An alarm sounded and was heard as something else. The aircraft climbed, and the air inside it thinned, and the people inside it lost the capacity to understand what was happening to them. The investigation answered how. It answered what. The question the record cannot fully answer is narrower and more persistent. In the minutes after that alarm sounded, with the wrong diagnosis forming, how close did the flight deck come to the correct one? That gap between the alarm and the understanding is where 121 lives were lost. The unsolved vault. Every case leaves something behind.